as you're watching this, here's what we're going to look at. Down here, on the bottom of this, the quadcopter, there's a camera. And that camera shoots at a square, okay? The way it shoots a square. You're going to see how that square changes as the height changes. On this side, it's going to monitor the height. As the height changes, the edge, so one side of the square, the edge is going to change. So as the height changes, the edge is going to change. And that's a linear relationship. However, the area, because area is edge squared, the area is not going to change in a linear fashion anymore. It's going to change as a quadratic. So here's the quadratic equation that it's going to follow. This will stay the same. What's changing is our x, which is our height, goes into this equation, and it in turn is going to change the y, our area, dependent variable here. So let's just look at, without the quadcopter moving, you can see on the demonstration, as I change the height, we change it to a meter, you can see how the square got larger. It stays a square, okay? It's like if you're working on a word processor or something, you grab something in the corner, it's going to change both dimensions, right? We go here, square gets larger. Go back down, it gets back smaller. It's changing length and width. All right, so that's the demonstration. That's all of it. This is just to sit here.
Like to say, I do.
Joking. All right. So if for some reason this comes out at you, just put your hand out, bump it away from you. It won't hurt you.
Hey, make it up to the neck.
Okay. So it kind of regulates itself here. It kind of tries to maintain at about a meter. It doesn't really get there, the calibration on it lets this stop. It stays between 0.7 and 0.8. So this is kind of where it levels itself off. Now as we change the height, you can see the area change. Alright? So you can watch the area change on here. You can watch the picture of the area change as well.
I think it's leaving the area.
So again, you increase it some. You can see that the area changed by, I think it was at 2 something, now it's at 9 or 10. So the area increased 7 or 8, or 5 times, where the height only changed by about double. Okay? Again, you can take it up as high as it'll possibly let it.
Then like hit the ceiling and like
The highest it's gotten all day.
like hit the ceiling, like start shredding the ceiling off and crap.
Why did you have to say that?
Because I thought it was gonna. I knew it was gonna happen.
It's your fault.
Can you bring it over here? It's hot.
It does put off a lot. It puts off a lot. Alright, let's see if it'll get. I don't know why it got off the thing that much. Okay, so again, let's see if it'll get it stay over on that. If it loses at night, it kind of loses itself.
We just don't want you to fly our drones, Mr. Faust.
What's that?
We just don't want you to fly our drones.
Yeah, I'm not very good at it yet. Well, I have no control other than the height of the thing. So, as you can see though, as we change that height, the area that this could shoot, the camera that this could, the picture it could take, gets larger and larger. Just like the camera on your phone, if you hold it farther and farther away from the picture, the image is going to get larger, the area that you can take a picture of.
I thought once you turned it off, it was just gonna go.
No, it reverses itself.
I thought it was going to come after you.
That's what I was hoping.
Yeah.
Really, dude?
Really, dude. Okay, so we're going to look at area, and the big part with this that I want you to understand is that it's not linear anymore, that it's not going to change directly the way length would. If you change the length or the width, it's going to change as a quadratic. All right? So this really, as far as geometry, is not the greatest example or the greatest demonstration you can do in geometry, but it's been really boring in here for the last 3 weeks. So maybe this is something that kind of helps you wake up today, and we can do this.
I think it's pretty cool.
All right?